All right, so we want to look at this thing about confidence intervals. And I want to relate them to hypothesis tests. So, suppose we had a hypothesis test where, let's use proportions, P equals, and let's go with 0.59. And HA alternate. Now, in this case, I'm going to now go to a two-sided alternative, and so not equal to 0.059. And let's just say, and I'm just using 0.59 because of our project and so forth, but let's just say we get some data where, and I'll use a different p hat. So p hat, our data, suppose we got something like 0.75, and when we created our distribution, now I'm just going to make a nice normal distribution sort of thing. So suppose when we created this distribution, here's 0.59, and say here's 0.75, and we found this area out here, this proportion, to be something like maybe 0.015. And now we have to double it for our p-value. So our p-value, again, two-sided test, so p-value equals 2 times 0.015 or 0.03. And so we reject our H0 that p is equal to 0.59. Okay, now, most likely since we got 0.75, what you want to say is, oh, well, so it's higher. Well, yeah, I think so, but actually what we want to do is sort of shift our focus. Now, and this is the way I'm going to relate these two things, the confidence intervals and the hypothesis testing. You don't have to be doing a hypothesis test to do a confidence interval, not at all, but I want to put them in this context of each other so you can kind of see what you might say with your confidence interval. So we checked this hypothesis, we got 0.75, and we decide that we don't want to believe that it's 0.59. But you see, that doesn't mean it's 0.75. Okay, what does it mean, or what can we say? Well, what we'll do is we'll take, okay, we made this interval, right? This was from 0.75, so this was, I should have used 0.6 to make my life easier, but we went up 0.16 this way, so we'll go down here. This was at 0.43. And what we did in this area down here, or this proportion, was also 0.15. And that's why we doubled it, because it was this two-sided interval. Okay, so, or two-sided alternative. So now, we made this interval here based on, or similarly, sort of based on, now we got this with our p-value, but we're gonna also base it on our alpha. But for now, let's start with just this. So we got this interval here inside that, anything, well, actually, yeah, I do have to redraw that. I thought I could say it without doing the alpha first, but no. Okay, so let me let me redraw it. There's our 0.59. Now I'm gonna put in our alpha at actually 0.025, and alpha here, this is 0.025 that way and that way, right? Because 5%, and so because that's the doubling idea, so we took half of our 5% and put it over on the right side, half on the other side, and our data, you know, here's our 0.75 was out here, and our 0.43 was out there, and I'm not, you know, I don't know what this is because I didn't try to make the problem that specific. Let's just, for the heck of it, say that this was at 0.69 and 0.49. Okay, so suppose that's where we were. Then you see anything in here, we would have kept H0 or failed to reject it. And out here, right, we reject H0, and out here we reject H0. Okay, there's the picture of our hypothesis test. Is we create this interval inside here where we would not reject H0, or would be forced to keep it. And it's based on our alpha. So alpha over 2 here and alpha over 2 there. Okay, that's based on our alpha, right? And we reject anything beyond that, and our data were beyond that. Okay, hopefully that makes sense, that that's the picture. Now, what we do with the confidence interval is, okay, we rejected H0 in this case, and the 0.75 is higher than the 0.59. So yes, it's very reasonable to say, well, I think the actual proportion is bigger than 0.59. Great. But do you really think it's 0.75? Well, that's my best estimate right now, but all we do is, I'm going to draw this a little bigger, but here's the 0.59, here's the 0.75. The original interval, right, good interval for H0 was in here, and it went, and I made this easy, it went 0.1 up this direction, and it went minus 0.1 down that direction. Let's see, that was a 0. Okay, 0.59. So, put zeros on the front of that. Okay, now, so what we do in a confidence interval is we just shift our focus and we take this thing and we just move it over to where it's centered on the 0.75. So I move it over. I'm going to draw it a little below it in this case, and it will look, you know, it will be in here somewhere, and if I draw that line, then you see there's 0.75. If I go 0.1 this way, that is at 0.65, and if I go the 0.1 this way, it's 0.85. And so what we're doing with a confidence interval, and what we would call this is a 95% confidence interval. Okay. Now why 95%? Well, because we used an alpha of 0.05. So if we go back up here and think of this, this was 0.95 parts of the whole, or 95% of the whole thing, is inside here, and just 5% from the alpha is outside. And so it's the same thing here, 95% of the data, 95% of the data. We're using the same distribution shape, and so we're just sliding it over our data instead of over our hypothesized mean. And we're saying now that, oh, okay, so we think that our best guess, because we got the 0.75 data there, is that this thing goes up and over and like that, it's shaped like that, and that 95% then would be in here. We'd find it that same way that we would with the known distribution. Okay, so our confidence interval is really the same idea as this region where we do not reject H0. Okay, it's just that we've grabbed it here and we've moved it so it's centered over our data instead. But so if we now sort of thought of our data as, well, that's our best guess. Our best guess is that the proportion is 0.75. But now if we take that distribution that we got and we center it over that, then we can go out here and say, well, okay, then we'll put some uncertainty on it, because again, this was just a sample. We sampled it, we got 0.75. Why would we think that's the exact answer, right? We shouldn't. But what we can do is say, well, that's our best estimate because that's all the data we have. But now we can put this distribution over it and say, you know, if you're willing to give me from 0.65 to 0.85, you know, with my best point estimate of 0.75, then I'm going to say I'm 95% confident the real mean, or the real proportion, okay, the real proportion is in here. Okay, so we've got this interval, and that's where we get this name, you know, 95% confidence interval is I'm going to, using my distribution information, you know, with the standard error and so forth, I can create this interval around my proportion or my mean that I found in my data. And you got to be a little careful, because what we're saying, see, is now we'll talk a little bit more about the 95% confident, but that we say the real proportion is in here somewhere. So it might be 0.85, it might be 0.65, it might be 0.75, it might be 0.683, you know, something like that. I don't know where it is, but I think it's in there somewhere. Now, what do we mean by 95% confident? Well, let's get a new page. And remember, you know, the real mean is here somewhere, okay? So, or the real proportion. So we'll say P0, the real proportion, is right there. Now, if I go collect data and so forth on this, and if this is my sampling distribution, then what I would expect is, you know, sometimes I would end up here, and sometimes I'd end up over here for my proportion, and here, and more frequently I'd be in this region, and much, much less frequently would I get answers out here. Okay, but here's the thing, is that the p hat is where I center my interval. So again, we'll try to make some more room here. Here is the original P0 and its distribution. And we'll say, you know, okay, there is your alpha regions and so forth. So here's alpha over 2, here's alpha over 2, and that's 1 minus alpha. So if alpha is 0.05, then this is 0.025, 0.25, and 0.95. Now, okay, I'm going to make another number line right here, and most of the time I'll get p hats in this region in the middle, right? Because that's more frequent. And so, oh, there's a p hat, and I center this interval here over that p hat, and you know, it's a little bit to the right, so I would get an interval, you know, a little bit to the right like that, and that would be my confidence interval. Oh, now I get another p hat, so there I'll call it p1 hat. That's the first time I did it. You know, another time I do it, I get a p2 hat, and I'll draw its interval, you know, and it's over here to the left a little bit, so its interval maybe looks, you know, something like that. Now notice that this interval and this interval, as we look here, they both contain the right answer, P0. Okay, so that's great. And what we would expect is that 95% of the time we will get a p hat that's in between these bounds here, and if the p hat we get is in between these bounds, its interval will contain P0. Okay, because, you know, if it's here or if it's here, well, we'll shove the interval one way or the other, but we won't shove it far enough that it won't contain P0 anymore. And how do I know? Well, because I look at these bounds here, and if I only shove it over this much, well, that's not that much. It's only that much. Okay, so you know, I'm only shoving it over a little bit. So 95% of the time, this interval that I make from my p hat is going to contain the right answer. However, 5% of the time, you know, I might get a p hat that's way out here, p hat 3, and this interval, when I center it, it's more like this, and that interval does not contain P0. P0 is way over here. Interval didn't contain it. That happens 5% of the time, whereas these types of intervals happen 95% of the time because of the data, because of the distribution. You know, we know, I mean, this is the whole point of the normal distribution and sampling distributions and so forth, is we know 95% of the time we should get samples that have these particular proportions for them. And 5% of the time will be out here. So that's what a 95% confidence interval is. You know, I'm 95% confident I got an interval like this one, and 5% confident I got an interval like this one out here. Okay? The 95% good, it contains the right answer. The 5% bad, it doesn't. Okay? And so that's what a confidence interval is doing for us. If we go back here to page 1 again, you know, how it relates to the null hypothesis and alternate hypothesis and so forth is that if you think of I guess I drew it down here. if you think of the non-rejection region versus the rejection region, okay, the non-rejection region is the size of our confidence interval, but then what we're doing is we're just moving it to center on our data. And if our, if we've done everything correctly, then we would expect that with alpha equal 0.05 and a 95% confidence interval, we would expect 95% of the time, and that's back to this thing, 95% of the time we end up with, we've calculated an interval that contains the right answer, and 5% of the time we would end up with an interval that actually doesn't contain the answer. And so that fits with the whole hypothesis testing idea, right, is that, well, here, if we go with alpha equal 0.05, then 5% of the time we will create, we'll get some data that if we were to create its confidence interval, it wouldn't contain this, even if that was the right answer, right? It should have had that. It becomes a type 1 error. Okay, so confidence intervals very related to hypothesis tests.